G'day kids. I thought while I'm waiting for this other sump to come back, that's awaiting fitment on the car, to make sure that all the prep work was done correctly, we'd have a look at the original piece that I cut off. Now obviously somebody's cobbled this together from odds and ends, and I thought we'd go through why it failed so badly. And there's only one or two things I would do differently to really improve it, to make it so it would be acceptable. This is not acceptable. I mean, the fact that the whole thing was covered in blue goo, you can see it on every seam. Wherever there's a weld, there's a leak. So number one for failure is the material choice. They chose gal. Yes, you can weld gal. It does require more prep. You can sort of get an idea for that along here. You can sort of see where they've started to clean the gal off just to get a slightly better weld. And, you know, one of the better welds of the actual job here is because they removed the gal. You can't weld through the gal. The reason for it is zinc atomizes at a lower temperature than steel will take to fusion. So you'll have literally gas pouring out from the surface, being zinc, that will then want to push into your weld, and that's where you get all the porosity and all the holes. So porosity is just holes like, see all the little pinholes? It's a bit hard to tell because someone's actually used this sump, which is kind of scary on an engine, the amount of stuff that would have been picked up and thrown around. But yeah, all the little holes are caused by when they've tried to create weldment, the zinc has vaporized and moved into the weld. So what we're going to do to correct this is material choice, number one. So I'm using hot rolled steel. Hot rolled steel is basically the same as gal, except it hasn't got a coating. The coating on it is black, and it is from the milling process. When they make the steel, it actually causes it to go black because when they roll it out, it's still hot when it's in a sheet. It hits the atmosphere, it pulls carbon, or carbon comes from the surface. Either way, the black oxide layer on the outside is purely just a carbon layer. You can grind it off, and the material underneath is exactly the same as what I would probably have used, which is this stuff, cold roll. Now, cold roll is the exact same material as hot rolled, except they wait till the material is cold, then they roll it out into sheet form, which then breaks all that black oxide coating off. Now, this stuff is really good to weld because it's pure and clean. There's no contaminants on it. Downside to it, it rusts like you wouldn't believe. Like, your fingerprints will show up a couple of days later if you leave it out and exposed. So it always has to be heavily oiled, heavily cleaned, then welded. Now, the reason I used hot rolled on the other piece, mostly because of material thickness, I wanted a nice thick sump. So this is 2 mil, where the thickest you can get in cold rolled is 1.1. So we're nearly 90% thicker with the hot roll. It's not going to matter because what we'll end up doing is taking the black oxide layer off. We'll take this off where we're going to weld it, not over the entire surface, just where we're going to weld it. So probably from about edge to maybe here, just where the fusion zone is. And what that will do will allow us to weld beautiful and clean with no inclusions, no porosity, no problems. Yeah, I mean, look, it's good that somebody had to go, but if somebody paid for this to be built, that's unacceptable. That's not something that should be done. Step away from the welder is sort of the commentary I'd give on that. But anyway, the customer's going to be here soon enough with the other sump, and we'll make a progress video on that as well. Alright, thank you for your time.